In this video, I want to transfer what I wrote here to an R Markdown file and then create graphs. So let's just copy everything here. And what I'll do is I'll just create a new R Markdown file like this. So this is going to be, let's say, Precept 5. And we don't need an author here, and I'll just do it like this. So this is just all sample text. I can just erase it. So I'm pasting everything that I wrote so far. Now this is all R code, so it would be eventually enclosed in R chunks. Now some of it should probably go in the setup chunk, which, because it says include equals false here, is not actually shown. So you don't really need to know like the housekeeping details about how I'm loading the dataset. So I'll kind of just hide it, although sometimes it's appropriate to not hide it as well, depending on what you want to communicate. So here I can write the text. So let's say, so first we'll initialize, not initialize really, but create the training and validation indices. And now this is just plain text, so it's going to be like this, but if it's an R chunk, I'll enclose it in triple text like this, and I'll include this R in order to say that this is actually R code and not some other language, which is also available. So let's also create a title. So let's say with different training set sizes. So this says that it's a small title, right? So like if you do this will be really big print. This will be relatively small print. So now those are the functions. So if I'm writing a lecture, I would say kind of like, let's define the function that create the training and validation set. So here, let's be a little bit more formal. So I'll say below are the functions for creating and a training and validation set with different training set sizes. So I'm improvising here. You could be even more formal, of course, and evaluating the performance of the model fit on the different models, I guess, different training sets. Okay, so here is the function. So this should all be inside the R block. So that's going to be like this. And now this we don't really need. This is the code to actually call the function. And now we'll say we experiment with different sizes of training sets below. And that's going to be like this. And let's call this something like performances, right? Because those are the performances. And let's see where we are thus far. So I'll save it. So I'll save it as P5 video. It's important that the extension here be .rmd. And now I can knit the RMD file and see what happens. Great. So here I have the function defined. So it's a little bit unfortunate that my lines are kind of long, but here it looks okay. Now here I see that there is a warning, which in my case I don't actually want. So what I can do is I can say warning equals false, and what that will do is it will not display any of the warnings that I get. Although sometimes you do want to see the warnings, right? So now there is no warning, so I get my performances. If I want to see what the actual performances are, I can say perfs, and just like if I had said perfs here, so here it's not defined, but if I had run it, I would have it defined, I would see it. So that is what this looks like. So this is my perfs. Now, one small point here, I had no problem loading the Titanic dataset here, but sometimes you would. So because here I just say read.csv titanic.csv, this assumes that I have titanic.csv in my working directory, which means that in general what I would want to do is I want to place titanic.csv or a similar file in the same folder as the RMD file, and then before I knit, I would do set working directory to source file location. Okay, so this was already done, so for that reason I did not need to do that. So okay, all right. So now that we have those performances, and let me actually define the functions again, and then actually run this and this and this. So I got the warning, of course, because I was not knitting the file, I was just like running things one by one. So now that is what we have. So I'll just start an R chunk here in order to start creating graphs. In general, what you should do is probably work in the R file. It's more convenient, and it's not as tempting to just try various things and net all the time instead of actually figuring out what the problem is by thinking about it. So I generally prefer to work in R file, but here, because we're also learning about R Markdown at the same time, I'll do it here. So what I want to do is I want to use ggplot, so I'll load ggplot2, and I'll remember to do that in here as well. So again, I'll do it in the setup because, well, people don't really need to know that I loaded ggplot2, so I don't want to show that. And because it says include false, I will not show it like that. So what I want to do, so I want to say ggplot, and then I suppose the data would be performances. And I'll say mapping equals to, so what is it equal to? Well, I know what the x-axis is, it's sizes. So I'll say x equals sizes, but I don't actually know what the y is because, well, I want the y to be sometimes this and sometimes this, right? So that wouldn't work. There might be other problems as well. So then let's try it. So here the problem is, well, perfs must be a data frame, and it's not a data frame. So what we can do is we can just create a data frame. So I can say perfs.df, like so, and then we'll create a data frame the usual way. So I'll say sizes is equal to sizes. So the column sizes is equal to this vector sizes. And then I'll say train performance is perfs1, so the first row of performance, like this. And then I'll say valid perf is perfs2, so the second row. Okay, so now that we did that, we'll say perfs.df, and let's try running that. So it seems okay, didn't show anything because all we said is axis sizes. We did not say what y was. The reason we did not say what y was is because it could be the train or it could be the valid. So okay, so let's add the first line. So I want a line, so I'll say geom smooth, and then in here I'll say mapping is y equals to, let's say, train.perf, like this. So let's try those two together. And as you see, that worked. So it gives us like a method that says that it used loss, which is fine. So we'll say method equals loss so that we don't get this message every time. Okay. Now the ribbon here, sometimes it's useful, so it shows the uncertainty, but it's kind of large and we didn't really need to know the uncertainty. So maybe what we'll say is SE equals false, I believe. Sorry, I said false. So this should have been SE lowercase. So that's going to be like this. And now, so that's one line, and what we see kind of makes sense. So here we have like a large performance and the performance drops. Now here this doesn't really make sense because the performance starts rising. Now that we would just chalk up to random chance. So now I also want to plot the validation performance, and I'll do it by saying that this is going to be valid perf. So what I'm doing here is I'm saying first do this layer, which is going to have y equals train perf, and because x was not specified, we just get the x that was specified when we called ggplot. And here we'll say, again, use the same x. We could have specified the x here, but what we did is we just specified the x for everything. We could override that later on. We didn't need to. But here what I'm saying is I'll specify the y like this, and again, I'll plot. So let's plot the two things together. And here's what we get. Now, this is not really nice because we don't really know the color here. So usually the color would indicate kind of which is which. So we can add a color argument here. So let's say that this is color red, and this is, let's say, green. And what you'll get is something like this. Now, this is this chunk, so we can say, okay, so here, like instead of experiment, we would say like we obtain the performances for the different sciences of training set below, and here let's graph performances. So let's knit this. So here you see you have the big headline, Precept 5, you have the smaller headline, and here you have the graph. Okay, so that's your basic R Markdown plus ggplot. So we'll do something more sophisticated with ggplot in the next video.